Okay, so this is our video number two on series. And for this one, we're going to look at the formula S sub n is equal to n over 2 a sub 1 plus a sub n. I like to call this little Gauss's formula. And if you do a little history research on Friedrich Gauss, you'll probably see this somewhere as a legend about little Gauss, adding up numbers. At any rate, let's go ahead and pick up the same sequence we had in video number 1, which was this sequence, 5, 8, 11, 14, 17, 20, 23, and let's just sort of stop there for a second. Okay, and remember that the formula we used to generate these terms, we had a sub n was a sub 1 plus n minus 1 times the difference. And for this particular series, the difference was 3, and the first term was 5. And we could find any term in the sequence using this. For example, let's see, 1, 2, 3, 4, 5, 6, 7. If we wanted the 7th term and we didn't know it, we could go 5 plus 7 minus 1 times 3. So the 7th term is 5 plus 6 times 3, which is 5 plus 18, which is 23. Okay, so that does allow us to find any term in the sequence. What we want to do now, though, is to not simply list the terms, but to add them up. So let's take the same sequence and replace all the commas with plus signs. Okay, so when you do that, you no longer have a sequence, you have what's called a series. So now we have 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23. So our sequence has now become a series, and we want to add these up. And the formula we're going to use is little Gauss's formula. We're going to use this formula right here. Now to do this, this is the sum of the first n terms. It's always going to be n divided by 2 times the first term plus the nth term. And to work this, you really need to know how many terms you have. So there's the last one, there's the first one. So it's pretty clear that a sub 1 is 5. Now 23, we could just sort of count these. Let's see, 1, 2, 3, 4, 5, 6. This is the 7th term, a sub 7. So let's go ahead and add these up using little Gauss's formula. So we got the sum of the first 7 terms is going to be 7 divided by 2 times the first term, which is 5. Right? A sub 1 is 5. And the 7th term, a sub 7, is 23. Okay, so at that stage, just sort of clean this up. This is 7 halves times 28. 2 goes into 28 very nicely, so 7 times 14, and 7 times 14 is 98. Okay, 98. I did it this way. 7 times 2, right? 7 times 2 is 49, times 2 is 98. Okay, so that's the sum of those first 7 terms. Okay. Now, what types of problems might you see? Let's look at a slightly different problem where I'm going to give you some terms. Let's say we've got some odd numbers. So we've got 11 and 13 and 15 and 17. And we just keep listing numbers. We go all the way out to 127. You would have to agree that 127 is in this list. Right? They're all odd numbers, and 127 is odd, so we're okay. So now I want to add these up. So I'm going to be using little Gauss's formula. It says we need the number of numbers divided by 2 times the first number plus the last number. Now, the good news is we know the first number. This is a sub 1. And we know the last number. That's 127, a sub n. But what I don't know is which number is this? Which number is this? It's certainly not the the 10th term, 1, 2, 3, 4. 5 would be 19, 6 would be 21, 7 would be 23, 8 would be 25, 9 would be 27. This is 127. Which number is this? Okay, so before we work the summation formula, before we add up these numbers, we are going to have to go back and look at the sequence formula and try to figure out which term that is. Okay, so there's sort of an embedded problem here. We know that a sub n is a sub 1 plus n minus 1d. Okay, we know the last term is 127. We know the first term, that's 11. We don't know how many terms there are, but we do know the difference. Notice that the difference is 2. These go up by 2s. So here is a formula now that will allow us to calculate n. And once we get in, then we can stick that right here and right here. And we already know a sub n is 127. Okay, so let's see. Off to the side somewhere, I'm going to take this formula and solve for n. That doesn't look terribly bad. 127, 11 plus 2 and minus 2. 127 is 9 plus 2 and subtract 9, so 119 is, subtract 9, Joe. Let's see if we can do that again. 118, right? 100 and 127, take away 9. 118, okay, is equal to 2n, so n is equal to 59. Okay, so this is the 59th term, and you know, yeah, certainly you can do arithmetic. At the end of the day, that's a pain in the neck. So feel free to use your calculator if you need. Okay, so we now know, we found that this term is in fact a sub 59. And of course, we could check that if we wanted to. You know, if you put 59 into this formula, you should get 127. Let's double check that. A sub 59 is supposed to be 11. That's the first term, right? Plus 59 minus 1 times 2. So the 59th term is supposed to be 11 plus 58 times 2. 58 times 2 is 116. Plus 11 is going to be 127. And sure enough, that's it. Okay, so we've got the right term there. Okay, so all that preliminary work, now we go ahead and add these guys up. Let's see, here is our little Gauss's formula. So the sum of the first 59 terms is going to be 59 divided by 2 times the first term, which is 11, plus the 59th term, which is 127. Okay, now at this stage, I think the calculator sort of screams, get my calculator out. These numbers are pretty big. So let's see, we've got 59 divided by 2 times 11 plus 127. 127. Okay, so I've got all that squared away. So 4,071. So the sum of these first 59 terms is 4,071. Okay. Now, there's lots of little exercises I've got set up on your class page. So if you want to look at them, they're also on this topics page. But we plan on doing them in class. Remember, this is our flipped classroom. So on Tuesday, the 3rd, right, we are going to work problems 1 through 11. It says homework set number 1. If you want to look at that tonight, that's great. But I don't expect you to do that. We are going to do it in class tomorrow. Okie dokie. That'll be the end of this particular video. 9 minutes.